In this question, we're interested in finding the integral of x e raised to power 2x dx. We're going to apply the method of integration by parts. When you're applying the method of integration by parts, let us have a good choice for our u and v. Remember that when you're applying the integration by parts method, the integral of v, let me just write down the whole thing. The integral of u dv is written as uv minus integral v du. So we're going to make a good choice for u and dv and then try to simplify this as much as we can. So for u, let me use a different color. This is going to be your u and then du there. So I'm going to take u to be x, and then dv is equal to e to power 2x dx. So obviously, du is equal to dx, and the v is the integral of e to power 2x dx. But this integral should be very easy because we just use u sub, and let me use a different color. By substitution, v is equal to 1/2 e to power 2x. So we have all the missing information. Let's write our integral as uv, which in this case is x, v, which is 1/2 e to power 2x, minus the integral v du. V is equal to 1/2 e to power 2x, and du, which is just dx. This makes our calculation much more easier. This is equal to 1/2 x e to power 2x minus, well, the integral of 1/2 e to power 2x is nothing but 1/4 e to power 2x plus constant of integration. So in applying the method of integration by parts, the choice of u is very important. Let us take a look at another example. So suppose we want to evaluate the integral of ln of x times square root of x. What's the choice of u? We're going to apply the method of integration by parts, everybody. Remember the formula. The integral of u dv is equal to uv minus the integral of v du. Again, what is a good choice? Should we take square root of x as our u or ln of x? So the best choice here is taking u to be ln of x. Later on, you'll see why is that. And let us take dv to be square root of x dx. du is equal to the derivative of ln of x, which is 1/x dx. And to calculate v is nothing but the integral of square root of x dx. V is equal to the integral of x to a half dx. We're going to use the power rule here. Remember that if you have the integral of u to power n du, this is u to power n plus 1 divided by n plus 1 plus constant of integration from elementary calculus. So our v is equal to, we have to add 1 to a half, you get 3 halves, so you get 2/3 x to power 3 halves. We have our v, we have our du, so let us follow the formula. This integral is equal to uv, u is ln of x, times v, which is 2/3 x times square root of x. You can write this guy as 2/3 times x times square root of x. When you have x to power 3 halves, this is basically square root of x to the third, or square root of x squared times square root of x, or x times square root of x. Very well. So minus the integral of v du. Again, our v is 2/3 x times square root of x, and then du is equal to 1 over x dx. So we can get rid of our x here. It makes our calculations easier. You can get rid of x and x. So here you have 2/3 times ln of x times square root of x, or let me just write down everything in different colors, so later on when you're going to see this, you don't get confused. Minus, well, here you have 2/3 the integral of square root of x dx. We already know how to calculate the integral of square root of x. We already saw that. So it's just on the right hand side. The integral of square root of x is 2/3 x to power 3 halves. So this integral is equal to 2x ln of x divided by 3 times square root of x minus 2/3 times, well, you have another 2/3 x to power 3 halves plus c. We can simplify this guy further as 2x times ln of x times square root of x divided by 3 minus 4 over 9 x times square root of x plus constant of integration. You could also simplify this further if you want to, all right? You could factor out like 2/3 x square root of x and write it in simpler form, or you can leave it as it is. Or simplify this as 2/3 x times square root of x, parentheses, you get ln of x minus 1 times 2/3. So let me write this guy down here for you, minus 2/3 plus constant of integration. Both of them are absolutely fine. Suppose you're interested in calculating the integral of x times cosine 5x dx. So what is our approach here? Well, we can use the integration by parts method. The integral of u dv is equal to uv minus the integral v du. But again, our goal is to have the best choice for our u to simplify this integral on the right-hand side. If this integral gets a little bit more complicated, it means that we made some mistakes and we need to go back and adjust the choice for our u. So this must be simpler. not more complicated. So let us take u to be x and dv be cosine 5x dx. Du is nothing but dx, and v, as you remember, is the integral of cosine 5x dx. By using u substitution, v is equal to 1/5 sine of 5x. Perfect. So our integral becomes uv, which is x times 1/5 sine of 5x minus the integral of v du. What is v? v is 1/5 sine of 5x, and then du, which is just dx. So this integral is equal to, so you have 1/5 times x sine 5x minus 1/25 cosine of 5x plus c. And since it already has a negative sign in front of it, negative times negative, it becomes positive. So integration by parts make it very easy for us to do the computation, right? Let me just rewrite this as cosine 5x. And here you have sine 5x. Next question for you. You have the integral of x minus 1 times sine of pi x dx. So what's the good choice for our u? What is a good choice for our dv? You could simplify this integral into the subtraction of two integrals if it's easier for you. But in applying the method of integration by parts, we have the integral of uv minus the integral of v du, right? So you have your u dv, which is equal to uv minus the integral of v du. So let us take u to be x minus 1, du is equal to just dx, and then v is equal to dv is equal to sine of pi x dx. So v becomes the integral of sine of pi x dx. So v is 1/pi cosine of pi x, but remember that you need to have a negative sign in front of it. So let us follow the formula. You have the integral of x minus 1 sine pi x dx, which now becomes uv, which is x minus 1, times v, which is negative 1 divided by pi of cosine pi x minus the integral of v du, negative 1/pi cosine pi x dx. And dx and du are the same thing, so let me use the same color. Okay, cool. So this guy can be written as, let me just write down the whole thing. You already know how to take this integral, 1 minus x divided by pi cosine pi x, negative times negative becomes positive, plus 1/pi squared of sine of pi x plus constant of integration.